Okay, welcome back. On page 205, they finally get to real concrete examples that are useful to you, like programming language analysis. It's called lexical analysis, where I break things up into tokens. For example, I need to know, for most programming languages, I need to know the token would be like a variable, or a constant, or an operator, or a keyword, right? And they're all separated by space characters. It could be a tab, could be a space, could be a new line. Some languages allow new lines to be in there without any trouble. Others have to have some special backslash things. And then there's grammar. For example, the operator precedence, like the multiplication has to happen before this. Associativity, control structure, like an if statement, then you have a then, and then you have an end if, those kinds of things, like, real honest to God structure. And so they use a parsing tree, and they show us some examples in the book, but they're not all that helpful, about how you would go about doing this. So in the real world, there actually are parsing engines out there that are pre-built, so you don't have to write one. Now, I'm not saying you can use that in your homework assignment. I'm just saying these things exist where you give it the list of tokens, and you give it the list of space characters, and you give it the list of all the rest of the things, and it will go through and do it for you and parse it all out for you. Fantastic work. And that's not what we're doing, because we're going to have to write our own. So in order to do this, there's a way you can describe tokens. Now, we kind of sort of did it here. Kind of sort of. In this guy. Okay, but there is a standard system for doing this. It's called the Backus-Naur form, BNF. And BNF is a standard notation that everyone can use to figure all this stuff out. So I looked up what the BNF looks like for the C# programming language. So let's just go look. Okay. So it starts off with, the grammars and the notation. So input, I'm going to skip over some of this stuff. And so what are line terminations? Well, it could be a carriage return. It could be a line feed. It could be a carriage return and a line feed. It could be all these other things. What are comments? Well, I can have a single or a delimited. And so a single line looks like that. And then a new line. It could be at the end and a delimited. And then we could have the asterisk guy, or and then we finally get in here and talk about, what is white space? What are the tokens? Tokens are, identifiers and keywords and integer literals, all these things. So let's do one, okay? I'm going to build one of my own. Let's say I want to write this calculator right here, okay? So how in the world would I create a BNF for this? Well, I have to have something called a digit. And it uses this little notation. So digits are going to be like 0. Actually, the way they do it is like this. Or 1, like this. Okay, I'm not going to do them all because that'll take up too much time. Dang it. Come on, dang it. Okay, so that would be digits. But are numbers only made up of digits? Well, sometimes they're not. So if I do a number could be equal to a digit, or it could contain a dot followed by some more digits. Ooh. Like that. So what's an operator? Well, an operator is going to be equal to, a plus sign. Right? For my little calculator. Boy, I cannot type today. Or a minus sign, or whatever. On and on and on and on and on. Okay, is that making sense? And so, if I kept going at this and maybe throw in the grouping, I would have a thing called an expression. Or an expression would equal a number with an operator. And another number. So I'm creating a BNF for a very simple calculator where all the digits exist. Numbers could have digits or a decimal point followed by more digits. Operators could be plus, minus, multiplication, division. And expressions are made up of these things. And then I probably want to say that an expression could have a sub-expression, right? So I probably want to do something like, expression could also have an optional one of these guys. Dang it, I cannot type today. Well, I'm not doing it right, but that's beside the point. Where I put it in parentheses, right? So expressions could have something with parentheses around them, right? Cool. All right. So that's creating a BNF. It's imperative that you know how to read one of these things to be able to make sense of things when it comes time to parsing, because this is telling you absolutely everything you need to put in your application. What is a valid digit? You need to know that when you're parsing it, right? What is an operator? Yeah, you need to know that. What is an expression? Yeah, you need to know that. Can expressions be nested? Yes, you need to know that. So the BNF is telling you everything you need to how to write one of these applications like this, okay? Mine was just simple words, but here I would have to say, are you an expression? Are you a such and such character? I would have to have lots of states being maintained and lots of transition between states. Okay, BNF diagrams. Okay, that's as far as we're planning on getting in this chapter. And next chapter we're going to talk. It's not going to be in the book at all, and it's going to be all about the practical application of regular expressions. So see you guys next time.